Ever feel like math is just a bunch of abstract rules you have to memorize? Well, today, we're going to unlock a mathematical superpower that you probably use every single day without even thinking about it. I'm talking about ratios and proportions. This is the hidden logic behind everything from baking a perfect cake to figuring out a map. So let's dive in. This quote just nails it, doesn't it? Understanding ratios isn't about being locked into a strict set of rules. It's about understanding the relationship between things so you can break the rules, innovate, and create. That's the real superpower we're talking about here, empowerment. All right, so here's our game plan. We'll start in the kitchen with the chef's secret code. Then we'll get the basic language down. After that, I'll show you a killer math trick for solving for unknowns. We'll look at the two different ways things can be related. And finally, we'll put it all together to solve some real-world problems.
Right. Section 1. Let's head into the kitchen. Because the kitchen is probably one of the best places to see how ratios aren't just for math class. They're actually a foundation for being creative.
Think about it. These simple number codes are the backbone of countless recipes. That 5:3 bread ratio, that's the starting point for pretty much any loaf you can imagine. And that 1:3 cookie ratio, that's your base for everything from a simple sugar cookie to some fancy holiday creation. Once you know that core relationship, you can scale it up, scale it down, and really make it your own. Okay, so we've seen why this is so cool. Now let's dig into the what. We're just going to quickly break down the two key terms you absolutely need to know: ratio and proportion. So first up, what even is a ratio? It's just a way of comparing two numbers. It can be a part-to-part comparison, like the amount of oil to the amount of vinegar in a dressing, or it could be a part-to-whole comparison, like the number of winning tickets compared to the total number of tickets sold. We'll see why that difference matters in a little bit. And a proportion, well, that's even simpler. It's just an equation that says two ratios are equal, that they're the same. For instance, the ratio of 3:12 is proportional to 5:20. Why? Because they both simplify down to the same basic relationship, 1:4. This whole idea of balance is the key we're going to use to find missing numbers. Now for my favorite part. Let's talk about the most powerful tool for solving these kinds of problems, the cross-multiplication trick. Seriously, if you have a proportion with one missing piece, this is the quickest, slickest way to find it. Let's look at a classic example here. We've got this proportion, 3/12 equals 5 over something. We'll call it x. Our mission is to figure out what x has to be to make this whole statement true. So how do we do it? It's actually super simple. You just multiply diagonally across the equal sign. So we multiply 3 times our x, which gives us 3x. Then we multiply the other diagonal, 5 times 12, which is 60. Now we have a simple little equation, 3x equals 60. To get x all by itself, we just divide both sides by 3. And boom, there you have it. X equals 20.
Okay, cool. So we know how to solve for a missing piece. But here's something you need to know. In the real world, things can relate to each other in two totally different ways. This is the difference between what we call direct and inverse proportion.
The difference is really intuitive. In a direct proportion, when one thing goes up, the other thing goes up too. Think about it. The more hours you work, the more money you earn. Simple. But in an inverse proportion, it's the opposite. As one thing goes up, the other goes down. Like the more people you have sharing a pizza, the smaller everyone's slice is going to be. And here's a great way to picture it, right? The car on the left represents a direct relationship. More gas in the tank means more distance you can travel. And the pipes on the right filling up a tank, that's an inverse relationship. The more pipes you use, the less time it takes to fill it up. See? Opposite directions. All right, it is time to put all of these concepts into action. We're going to take what we've learned and tackle a couple of common problems where knowing about ratios and proportions is the absolute key to getting the right answer. Okay, here's a classic one, and I bet you've wondered this yourself at some point. If you know how tall something is and how long its shadow is, you can actually figure out the height of any other object just by measuring its shadow. This is a perfect example of a direct proportion problem, because as an object's height goes up, its shadow length goes up at the same rate. So the very first step, and this is super important, is to get everything organized and make sure all our units are the same. Let's just convert everything to centimeters to make it easy.
We set up our proportion like this. The pole's height over the pole's shadow equals the tree's height. That's our unknown x, over the tree's shadow. So that's 560 over 320 equals x over 500.
And now? We just do our cross multiplication trick. We multiply 560 by 500, which gives us 280,000, and that has to equal 320 times x. So we just divide 280,000 by 320, and we get our answer. X is 875 centimeters. We convert that back to meters, and there it is. The tree is 8.75 meters tall. No ladders needed.
Let's try another one. This is a super common scenario. Remember when we talked about part-to-part ratios? Well, sharing problems are the perfect place to use them. Here we've got two friends, Liam and Nathan, and they need to split 60 pounds in a 1-to-3 ratio. The method here is really straightforward. First thing you do is add up the numbers in the ratio to find out the total number of parts or shares. So 1 plus 3 gives us 4 total parts. Next, you take the total amount of money, the 60 pounds, and you divide it by those 4 parts. That tells you how much one single part is worth. In this case, it's 15 pounds.
And for the final step, you just hand out the shares. Liam gets 1 part, so that's 1 times 15. He gets 15 pounds. Nathan gets 3 parts, so that's 3 times 15, which is 45 pounds. And if you add them together to double check, 15 plus 45, yep, that's our 60 pounds. Perfect.
So you see, ratios and proportions are so much more than just some boring topic in a math book. They're like a hidden code that describes the relationships behind recipes, buildings, maps, and so much more. They're a tool for understanding how the world around you is put together. So my final question to you is this. What part of your world are you going to go out and decode now?